Let us move to the next topic. So far we have seen the models from the starting like LPP models. Then we have seen we have seen the simplex. Then we have seen the transportation. Then we have seen assignment. We have seen sequencing. We have seen the network models. Then we have discussed about inventory. Then today and yesterday we have discussed about queuing. Are all in all this case, aren't we making any decisions? We have seen simplex, transportation, assignment, sequencing, network, inventory, queuing. Are we not making any decisions out of it? Then what is the importance about this decision theory is? So that is the first question which has to be addressed. That is, yes. In simplex, we have seen the maximization function, the minimization function, the maximum profit, the minimum cost, okay, the nutrients required, advertisement models we have seen, okay, agricultural models we have seen to maximize and to minimize, etc. Transportation, we have seen, we have find the optimum transportation route. Assignment, maximization and minimization, how to give the assignments we have seen. Sequencing, how to find the elapsed time and how to give a sequence in various cases that we have seen. So in network models, project management, minimal spanning tree, shortest path algorithm we have discussed. Inventory, the basic EOQ and price break models with shortage, without shortage we have discussed. Queuing also, basic queuing we have discussed. So are we making any decisions in these models? Then why to go for this decision theory separately? We are making decisions in these models also. Okay, we are making the decisions in these models also. So decision you can able to make, so decision making is an integral part of any business organization. So they're selecting the best among several decisions through a proper evaluation of the process involves parameters of each decision environment. So example on decision making are capacity planning, location planning, equipment selection, product and service design, etc. So these all things, these all things are some of the decisions which is normally taken in the case of manufacturing industries are concerned. Okay, so anyhow. These are the steps in the decision theory. Clearly define the problem. Yes. Okay. List the possible alternatives. Yes. Transportation and all. We have seen the metrics. Okay. All the alternatives are known to us. If you choose an alternative, what will happen? That is also known to us. Then from that, identify the possible outcomes. Yes, we have discussed and we have seen. List the payoff or profit of each combination of alternatives and outcomes. Select one of the mathematical decision theory models. Apply the model and make your decision. Okay. Now, from this steps, you can see to that list the possible alternatives. Okay. Sometimes you will know the possible alternatives, but exact outcome you are unable to know. So far, we in all the models, whatever we have discussed, we know each and every course of alternative, and if you select that particular alternative, what outcome you will get. That is exactly known to you. So when it is known to you, you have the past data, you have every information related to every possible outcomes, and from that you are making a decision. In the case of transportation model, by using northwest, least cost or Vogel's approximation method, you find the initial solution and then later you apply the modified distribution method, the MODI method or UV decomposition method to find the optimal transportation solution. So in the case of, in whatever the case so far we have solved, we know each and every alternate, and from that alternates we are choosing the best possible solution with the help of appropriate mathematical tools. Okay, now there are cases where you don't have any data is available. For example, if I am launching a product newly into the market, I don't know how the market is going to behave, whether it is a supportive market, okay, whether it will behave in the vice versa, that is not known to me. So the data is not available. Okay, then there are cases where datas are there, but they are not exactly categorized. Okay, some data is available, but not full informations are not available. You know the possible alternatives, okay, but you don't know the exact possible outcomes. Okay, so in that case, how to make the decision? The first part, the whatever we have seen so far, they are very easy. You need to know what tool you have to apply. You need to know what model it is, and accordingly, whatever its objective is, you can match the tool. You can get the output. But there are cases where no data is available and partial data is available. For that also you need to make the decisions. Okay, that is what basically the decision theory means. Okay, so the transportation or assignment or network or queuing or inventory, the models so far whatever we have seen, we are making the decision, we are giving the decision that product A to be manufactured, product X2 to be manufactured. You have to travel in a route like this. A traveling salesman has to go in a route like this, so its cost or time is minimum. If you see the project network, this is the project duration. If I want to reduce the project duration, these activities can be crashed. Okay, so these activities, if I am crashing, there's a term called resource allocation is there. I can allocate the resource suitably. So we are making the decisions only. Now, in that, whatever the past cases, we have all data, all informations are available. If that is not available, how to make the decisions? That is what our focus will be in this particular module called as decision making is. Yeah. So you can see this is what I told you. There are three types are there. First type is decision making under certainty. Okay. That is decision maker know for sure that is with certainty outcome or consequence of every decision alternative. Okay. So how, if I choose one way, what will happen? If I choose the other, what will be my output? What is the excess amount which I has to pump in if I choose the alternative? So that is the model number one, decision making under certainty. The second one, decision making under uncertainty. So decision maker has no information at all about various outcomes or states of nature. Okay, Decision maker has no information at all about various outcomes or states of nature. That is, if I am launching a product, a new product to the market, or if I have modified my product and if I am launching it as a new product into the market, how the market is going to behave, that is not known to me. So in that case, so whether to launch, whether to test launch it, okay, whether to put some models initially as complementary and see how the people reacts to it, then go for the actual product release. So likewise, so that is the case of decision making under uncertainty. Now the third case is decision making under risk. Decision maker has some knowledge regarding probability of occurrence of each outcome or state of nature. Okay. So a probabilistic, so it's not a deterministic, it's a probabilistic values you can able to generate, and based on that probabilistic condition, you can make a decision. So that is called decision making under risk. Okay. So the first part we have clearly discussed, we have already seen the first part. Okay, the first part, so I will not go into the first part at all. The whatever the tools, whichever so far we have seen, will falls into the category of decision making under certainty. Okay. Now the second case, type 2, decision making under uncertainty. Okay. So if the decision maker does not know with certainty which state of nature will occur, then he or she is set to make a decision under uncertainty. Okay. So there are methods are there to make the decision under the uncertain condition. So the first one, that is called as maxi-max criterion. Okay. I had if there are conditions will be given and payoffs will be given. So among the row wise, you have to find the maximum, and from the final column you can again take maximum. So that is what is called maxi maxes. Okay. So maximum, and from that find the row maximum, and from that row maximum, what is the column maximum is. So that is the maxi max approach. So that is also called as optimistic approach. Then that is called as maxi-min criterion. That is, you are finding the maximum among the row, and from that you are finding the minimum. Okay. So if you are telling that condition, you launch a new product into a market, and if the market doesn't favors me, okay, I launch a new product into the market and market doesn't favors me, so my loss I want to be minimum. Then you go for these kinds of criteria. The second one, the maxi-min criterion. The third one, mini-max, or it is called as regret. Okay, the mini-max, or it is called as regret criterion. So minimum you are finding, and from that minimum you are taking the maximum. Okay. Then you have a criterion called Laplace criterion. So Laplace criterion, you are providing equal choice for all course of action, and you are calculating the final outcome, and for the final outcome you are making the decision. Then the next is called Hurwitz criterion. So in Hurwitz criterion, there is a degree of optimism will be given, normally called as alpha and 1 minus alpha. If it is good, you have to multiply that value with alpha. If it is bad, you have to multiply that value with 1 minus alpha, and you have to make a decision. Okay. So these are the common tools which are there for making a decision under uncertain condition. Yeah. So it is still a detailed condition is given, maxi max. Choose the alternative that is the best of the best. Okay. The rule is for the optimist who has high expectations and prefers to go for broke. Okay. The maxi min. Choose the alternative that is the best of the worst. Okay. The best of the worst. The rule is for the pessimist who anticipate the worst case for each alternative. Okay, so Laplace, that is that I told you, that is a weighted payoff you are calculating, where each and every course of action have got equal probability. Okay, that is called as a Laplace criterion. Okay, so you can see if there are n events, the importance or probability of each is 1 by n. So they add up to 1. So this rule is for the realist. Now the next is called minimax regret. So choose the alternative with the best word regret. Calculate a table of regrets or opportunity losses in which the rows represents the alternatives and column represents the event. So a regret is the difference between a given payoff and the best payoff in the same column. For an event, it shows how much is lost by picking an alternative to the one that is best for this event. So the regret can be lost profit or increased cost depend on the situation. Okay. So that is the fourth criterion. Okay. And there is a last criterion also is the okay, last criterion is also that is the fifth. Okay, that as told you as a Hurwitz criterion. Okay. So we will see how to proceed when a problem is given, how to make a decision in this regard. Yeah. So there is a marketing strategy is given here. So consider the following problems with two decision alternatives. So I need to make a decision D1 and D2 and two states of nature. Market repetitive and S1 is market repetitive and S2 is market unfavorable. That is, you can see D1, D2 are, you can see they may be the products. Okay, they may be the new products which I am going to launch in a market. So these are the two products. So D1, D2 are the products. So if the product D1 is successful, okay, if the product is launched, okay, and the market gives me a favorable response, you can see that I can get a profit of maximum 20 out of it. Okay, the payoff. This is called as the payoff matrix. Okay, so the payoff matrix gives me the information that if based on what all things I need to make the decision and what are the states of natures are available. So in this case, the market S1, if it is favorable, then I will get a profit of 20 rupees. If the market is unfavorable, I will end up with only 6 rupees as my profit. Okay, so for an unfavorable market. Same way, if I launch the product D2 in a favorable market, my return will be 25. Otherwise, the unfavorable market, my return will be only 2. Okay, so now if you want to make the decision, okay, see for example, if I want to make the decision by using the max criterion. So I want to make the decision whether to go for D1 or whether to go for D2 and as to what it will return. So if we see among these two rows, so 20 and 60, the first, this is maximum, and then from that, the maximum you have to select. So among this matrix, the D1, the largest is 25. So I return the 25 here, sorry, 20 here. And in this 25 and 3, the largest is 25. So return here. So the maximum among D1 is 20. The maximum return among D1 is 20. The maximum return among D2 is 25. Among this 20 and 25, still the maximum value is D2. Okay. So as per your max criterion, you can see to that you can launch the product D2 in the launch D2 expecting that the market is favorable and you will get a return of rupees 25 for your effort. Okay, so this is what you are making as a decision. Now if I change the terms as minimax, okay, now if I change the term as minimax, If I change it to mini max, the first term is mini. So mini among D1 is 6 and D2 is 3. Okay, and the maximum among that is D1. Okay, so this will be the decision based on mini max. Okay, so though my product, so though my market is unfavorable, I'll get at least a profit of rupees 6. Okay, so one will be optimistic approach, the other will be pessimistic approach. And sometimes the payoff matrix may be cost, sometimes the payoff matrix may be profit. So if it is a cost, one method, okay, will be suitable, the other will not be suitable. So that also you have to think while solving the problems using these approaches. Yeah. Okay, so I told you the optimistic approach, maxi max, the decision is to choose D2. We have discussed it. So an optimistic decision maker would use the optimistic approach. All we really need to do is to choose the decision that has the largest single value in the payoff table. The largest value is 25 and hence the optimal decision is D2. Yeah. Now, maxi-min approach. This is also I told you. So, a conservative decision maker would use the conservative approach, list the minimum payoff for each decision, choose the decision with the maximum of these minimum payoffs. Okay. So, we are finding the minimum and from that minimum, we are finding the maximum. So that is the way. Okay, so that is the way normally the decision analysis are being performed. Yeah. Now minimum regret. Okay. So now for the minimum regret approach, first compute a regret table by subtracting each payoff in a column from the largest payoff in that column. The resulting is regret table. See, for example, here the same table here. So it is 20 and 25, 6 and 3. Column wise, the largest among these two is 25. Okay, so 25 minus 20 and 25 minus 25. Here it is 6 minus 6 and 6 minus 3. So when you did it, you will get a matrix like 5, 0 and 0, 3. Okay, now among this you are finding, so it is mini max regret. So first you are finding the maximum. Okay, so the maximum among this. So the maximum among this is 5 and the maximum among this is 3. So in that you are going for the minimum. Okay, so the minimum here is 3. So your decision is to go for D2. Here what you have to understand, well, one more thing is that whatever the criterion you are choosing, you will get a decision. Okay, don't never ever expect that all the decision criterion will end up to the same result. That will not happen. Each decision criterion will give the different results. Okay, so based on what approach you are using, you are getting the decision. Okay, so that is the third, mini max regret. Now equal likely or Laplace criterion or equal likelihood or Laplace criterion. So it is average you have to select. Okay, so how to select the average? The first case here I had 20 and 6, 25 and 3. So this will all two terms are there. So it will be 1 by 2 into 20 plus 6. Here also 1 by 2 into 25 plus 3. And when you take it like that, so you will get the value is 13 here and here you will get the 14. Since if you are taking it as a profit condition, your selection will be D2. Okay. If you're taking it based on a profit, largest profit, so the largest value D2 will be your decision. Okay. Now the criterion of realism or Hurwitz. So in this, as I told you, there will be an alpha value will be given. So the alpha will be the alpha value. Okay, you can see this is supposed to be that alpha equals 0.8. That is 80%. You are telling that maybe that the market will be a favorable, and 20% you are saying that the market is going to be unfavorable. So in that case, 0.8 into 20 plus 0.2 into 6, you will get a value. Same way, 0.8 into 25 plus 0.8 into 2, you got a value. From that, if it is a profit, select the largest. If it is a cost, select the lowest. So often called weighted average, the criterion of realism or Hurwitz decision criterion is a compromise between optimistic and a pessimistic decision. So first select coefficient of realism A with a value between 0 and 1. When A is close to 1, the decision maker is optimistic about future, and when A is close to 0, decision maker is pessimistic about future. Okay, so that is a condition. So if it is point A, it is optimistic. If it is point 2, then that is pessimistic. Okay, so a favorable market, if he is expecting, he will have a closer value equals to 1. Vice versa, he will go for a closer value equals to 0. That's the way you are finding the payoff. From that payoff, based on the cost or based on the profit, you are making the final decision. So these are the tools which you will be using in the case of decision making when the past data, when the complete past data is not available with you. Yeah. Okay, now this is an example. Okay, so this is an example. So you want to make a decision to purchase. Okay, so decision, an investor wants to decide which of the 3 property to buy. So an apartment building or an office building or a warehouse. Okay, good economic conditions and poor economic conditions. So apartment building will cost $50,000. Office building will cost $1 lakh, and a warehouse will cost only $30,000. If it is a poor economic condition, it is you will end up that rate may be somewhere around $30,000. For an office building, it may be $40,000, or a warehouse will be $10,000. So the given matrix, that is called as the payoff matrix or payoff table. And you need to make the criterion, you need to make the decision by using maximax, maximin, minimax, minimax regret, Hurwitz, and equal likelihood Laplace criterion. Okay, tell me what will be the decision in each cases. Tell me what is the decision in each case is.
Maximax office building.
Maximax
Office building.
Maximax is office building. Okay, right.
Maximin apartment building.
Maximin. So maximin.
Apartment building.
It is maximin is not asked. It is minimax is asked.
Maximin also asked, sir.
Okay. So maxi. Yeah. Sorry, sir. I didn't see. Yeah. So maximin is first you have to find the minimum. You have to find the minimums, and from the minimums, you have to go for the maximum. Okay, so that is apartment building, second criterion. So first criterion, it is office building. Okay, second criterion, it is apartment building. Yeah, right. Now, minimax.
Minimax is warehouse, sir.
That is maximum among that. Minimax is warehouse. Okay. Now, minimax regret. You have to make a regret table by taking the largest element and subtracting it from all other elements. So it is 1 lakh. So that 50,000 will remains as it is, 50,000. Yeah, what will be the decision under the next case? Minimax regret. Okay, let me see. Okay, so the first one we have seen the maximax, right? Maximin also we have determined. Regret criterion. Okay, so we have made it is 50,000, 0 and 70,000, 0, 70,000 and 20,000. So the minimum regret value. So go for apartment building. Okay, in this case also the decision will be to go for apartment building. Okay, and the final one, Horwich. Okay, so alpha value is not given. It is assumed to be as 0.4 and 0.6. So you got the return, and the best return is for 38,000. So you that in that case also the decision you are making it as apartment building. So you can see in all, when you are changing the approach, your decision is going to change. Okay, when you are changing your decision, your result is going to change. Okay, no other change is happening. Okay, there will not be, you not in that sense, you will not get a common decision by using the various tools. So based on the tools whatever you are selecting, your decision is going to change. Okay, so is the methodology clear?
Yes, sir.
Yeah. Okay, so this is the final one. Maximax office building, Maximin apartment building, Minimax apartment building, Horwich. No, I think one thing we have made a mistake. So Minimax, so maximums, maximum Minimax. Yeah, Minimax they have taken it as a regret criterion. Okay, right. Okay, so that's the way you are making the decision. Okay. Yeah. So there is a problem is there on the screen. So strategies and payoffs are shown over there. Okay. So get me the results by using the methods. Tell me.
According to Maximax S1, sir.
According to
Maximax.
Max S1. Okay. Right. Next one.
Sir, according to maximum, there are all three possibilities. Like two possibilities, three possibilities. So how to decide that?
Maximin. Maximin, the maximin. So first the minimum. Min, no,
3 lakhs.
no. First, among S1 you are finding the minimum.
Oh, okay, sir. So S3, sir, maximum.
Maximin. So yeah, in that case the decision is S3. Right.
According to Minimax S2, sir.
Minimax. So maximum is 3, 5 and 3. Sorry, 7, 5 and 3. From that S3. Yes. Other thing, you have to calculate it. If alpha value is given, you can apply the Hurwitz criterion, or else you can go for Laplace criterion. So Laplace criterion, it will be 1 by 3 of 7 lakhs plus 3 lakhs plus 1,50,000 for the first strategy. Second strategy, it is 1 by 3 of 5 plus 4.5. Third is 1 by 3 of 9 lakhs. So last is 3 lakhs. Last value is 3 lakhs.
According to Laplace S1, sir.
Yeah. Okay. Right. So that is the way you are making the decision in this particular cases. Okay. So there is a question is there in my screen. You can just take a screenshot. Okay. You can just take a screenshot. Okay.
Hello,
So
sir.
this is, yeah. So you can take the
Sir.
screenshot. Yeah.
Sir, one small doubt, sir. For
Yes, please.
minimax regret, sir, first we'll convert that matrix to regret matrix, then we'll find the minimum of maximum. That's all, no, sir?
Yes.
Okay, sir.
So minimax regret, first you have to convert into regret. Then from that tables, okay, from that tables row wise, okay.
Row wise,
So row
maximum,
wise
we should take.
maximum. From that
Out of that
maximum,
minimum.
yeah, from that you find the minimum. That is column minimum. Okay.
Okay, sir. Yes,
That
sir.
is how you are making the decision. Right. So these are the ways which we will make the decision making under uncertainty. Okay. So the complete data we don't have. We don't have the full information to make the decisions. Okay. Right. Is that clear? Is this part is clear?
Yes, sir.
Okay, now you got a matrix, and if the matrix is cost, okay, if the matrix is cost, which methods will you suggest? And if the matrix is profit, which method will you suggest? Yeah, okay, I'll give you a problem on tomorrow in that aspect. Then we will move to the next type of decision making. Okay.
Sir,
So yes,
if
please.
it is cost, we'll think as a pessimistic one. I mean, pessimistic person. If it is profit, then we'll think as optimistic.
You have to tell me which methods.
Yeah, pessimistic in the sense like was the minimum of max.
So if it is a cost, minimax,
Yes, sir.
minimin, and Laplace.
Yes, sir.
If it is a profit, you can go for maximin, maximax, and Laplace. That is maximin in gain criterion.
Okay, sir.
Yeah. So if that is the case, I will move to the next topic, decision making under risk. Okay. How to make the decisions under risk. So I'll stop here right now. Good afternoon. I hope I am audible and my screen is visible.
Yes, sir, you're audible.
So we were discussing about the decision theory in the yesterday's class. So we have seen the three types. Okay, under certainty, under uncertainty, and under risk. So certainty we have already discussed. They all falls under to the category of certainty. So uncertainty, the tools we have discussed on yesterday, the maxi min, maxi max, regret, Laplace, Hurwitz criterion that we have discussed on yesterday. And we have seen some problems also, how they are being done and how they are getting changed. So we have discussed with some examples also. We have seen some results in that part. Okay. So I hope that part is completely clear and you don't have any doubt or anything like that is not there in that part. Okay. So I hope that is clear. So equal likelihood, so maxi max, maxi min, another metrics also we have discussed. Okay. So any doubt if we have, we can discuss, or else I'll move to the next part, that is decision making under risk. So we haven't touched anything. So okay, so it is decision making. So decision making. So it is the first one as certainty. Okay, so certainty. The second one is uncertain. And third is under risk. So so far all your transportation, so your LPP, okay, your transportation, okay, your assignment, your network, okay, inventory, then inventory, then queuing. So all falls under to the category. All these are the tools which you can. So these are the tools which you can use in the case of certainty. According to your objective, you can choose each and everything. So under uncertainty, we have discussed as maximax. Okay, maximin, maximin. Okay, then mini min is also will be available. Okay, mini max is also available. You will have regret. you will have Laplace, and you will have Hurwitz. Okay, so these are the tools which you can use under decision making under uncertain. Now we will see under risk what all the tools we will have. So under risk, the common important tool that is called as expected monetary value. Expected monetary value, EMV. Then you will have expected opportunity loss. Opportunity loss, that is EOL. Then you will have expected value for perfect information. So that is EVPI. Okay. So these are the three tools which commonly used to make decisions under risk category, calculating the expected monetary value. Okay, expected monetary value, expected opportunity loss, and expected value for perfect information. Okay, what is this first criterion is? What is this first criterion? Expected monetary value, or how an risk problem looks like. Okay, so the risk problem, how does it looks like? So here you have some information of data will be available, and that will be in the form of probability. Okay, that will be in the form of probability. So some information about the data is known to you. Based on that, you will have the probabilities you have to calculate, and using the probability you can see you can find a solution by using any of these three methods: expected monetary value, expected opportunity loss, or expected value for perfect information. So let us see a problem, and let us see how it has been processed over. Yeah. Okay. So the same problem, whatever is given over the whatever the problem is given to you earlier. Okay. So expected value is computed by multiplying each decision outcome under each state of nature by a probability of its occurrence. Okay. See, for example, your good economic conditions has a probability of 60%, and the rest is for pure economic condition. So the probabilistic value for good economic is 0.6 and poor economic is 0.4. Okay, so in the case of apartment building, so you will get an EMV value of 50,000 into 0.6 plus 30,000 into 0.4. You got some value. Okay, now office building also the same way, 1 lakh into 0.6 plus minus 40 into 0.4. You got a value. Warehouse, you say that it is 0.6 into 30 plus 0.4 into 10. You got a value. And among these EMVs, the maximum one you will select. Okay, among the EMVs, the maximum one you will select. Okay. Yeah. So I'll come to, I'll give you some, let me see. Yeah, that's not good. I'll give you a simple problem. Okay, now a person wants to sell strawberries. So, okay, so a retailer purchases strawberries. Okay, so So retailer purchases strawberry. Okay, strawberry. So he used to purchase strawberries on every morning. Okay, every morning. The cost of the purchase is rupees 60. Okay, rupees 60 per case. Okay, rupees 60 per case, and he will sell it. Okay, and sells at rupees 90. Okay, any unsold. Okay, any unsold will be okay. Any unsold will be disposed of. Will be disposed of next day at a price of rupees 30. At a price of rupees 30. Okay. And whatever is unsold, so that is the case. The next day he has to sell it at a price of 30. So nothing he is supposed to left off. So there is a 120 days data is available. Okay, there is a 120 days data related to sales is available. Okay, so related to sales is available. So that data is something like this. Okay, it will be it is something like this. So the cases sold and number of days. So cases sold is varying from 12, 13, 14 and 15. And number of days, 12 cases sold as 12 days. That is 12 days. 13 cases sold as 24 days. 14 cases sold as 36 days. 15 cases sold as 48 days. So put together you can see it is 120 days. Okay. So now your question is to determine. Your question is to determine how many cases the retailer should purchase. How many cases the retailer should purchase every morning. Okay. So this is a problem. Okay. So I had only a limited data of 120 days is available. Past 120 days data is only available. So among that, you can see he can purchase normal purchase is 12, 13, 14 or 15, and the demand is varying from 12 to 48 for the cases. Okay. So if he is buying at a rate of 60 and selling at 90, and anything unsold that he has to dispose of on the next day at a salvage price of rupees 30. Okay. So how much cases he should purchase? So that is the question. So how to find it out? Previously, you can see that when you have directly the probability is given, the payoff is also given. Multiply the payoff with your probability, you will get the EMV result. But here no such information is that, only 120 days data is given, probability is not given, and also it is not a exact cost metrics or a profit metrics is not given. So how to proceed? So first one, from this you have to make a conditional profit table. Okay, a conditional profit table, that is also called as payoff. So previously in that slide, the payoff is directly given. Okay, by multiplying with the probability, you can able to get the results, but here that is not given. So how to proceed? So that is the question. So first table is to represent the conditional profit values or payoff. Okay, so that is called as the payoff table. Okay, that is called as the payoff table. So the first column is state of nature. State of nature. So here that is demand per week. Okay, so demand per week. So the demand is given as 12, 13, 14 and 15. So here this is the probability. This column is for finding the probability, right? And this is to find conditional profit. Okay, conditional profit. So also you can say that here it is a conditional profit. So it is based on the purchase per day. Purchase per day. So he can purchase 12. Okay, he can purchase 13. He can purchase 14 and he can purchase 15 cases per day. Okay. Yeah. So now how to find the values? Okay. Now probability. What is the how many days of data is given? 120 days. Okay, 120 days. So what is the percentage of demand on 12 cases? There is a 12-day demand. So the fraction out of 120, so that will be equal to 0.1. Okay, so the probability of selling 12 cases is 0.1 since the 12 cases are sold on 12 days. And the next 13, the value is 24. So the probability value is that 24. What is the fraction of 24 in 120 days? So that is 0.2. Okay. The third is you can go get 36. So 36 cases. So 36 cases. What is the 36 days? So what is the probability of 36 days in 120? So you will get the value as 0.3. And finally it is 48. So what is the probability of 48 on 120? So that is 0.4. And if you sum it up, you will get an exact value of 1. Okay. So when you sum it up, the probability value, you will get a value of 1. Okay. Now what is the profit per case? Okay. Now what is the profit per case? You are purchasing at a rate of rupees 60 and you are selling at a rate of rupees 90. So profit per case is rupees 30. Okay, and if the item is not sold, the next day he is selling. So loss is also rupees 30. Okay, whatever is unsold that he is selling on the next day, the loss is also rupees 30. The profit here is also rupees 30. Okay, now we will fill the rest part. So the demand is 12 and he is able to sell. Okay, so this is the purchase per day. Okay, and this is the demand. So demand is 12 and he is able to sell the 12 units. Okay, what is the and in his, so the other way I'll put. So demand is for 12 weeks and in his stock he has 12 cases are available. So what is the situation? That 12 cases, whatever the demand is that is only available within, so he can sell it completely. So he will get a profit of 12 into 30. Okay, so he will get a profit of 12 into 30. So that is rupees 360. Okay, so 13 is the demand and 12 in only stock. Demand is 13, but in stock only 12. What he will get? He will get only the profit for the 12 cases which he is there in the stock. So that is also rupees 360. So 14 is the demand, 12 in stock. So whatever the case, he will get only 360. Since in a stock, he has only 12 cases and whatever the cases, he can sell only that value what he is having. Yeah. Now we'll see the next one. 12 is the demand. Okay, the demand is for 12 and in stock he has 13. Okay, the demand is for 12 on in stock he has 13. So what the situation is? So 12 he can sell it off. So 12 cases he can sell it and he will get a profit of 30. Okay, and one. Okay, and one case the next day he can sell only for a 30. So for 12 cases he will get a profit of 30. One cases he will end up a loss of 30. Okay, are you agreeing to it? 12 is my demand and 13 I kept in the stock. So 12 I can sell it off on that same day for I'll get for a profit of 360. The one case which is not sold on that day, next day it is disposed of with a loss of 30. So 360 minus 30, it will end up as rupees 330. Okay, so that is rupees 330. So here also the similar case you can see over here. So 12 is only demand. So 12 into 30. Okay. Minus 2 into 30. Okay. So the totally he can get a profit of rupees 300. And finally here that will be rupees 270. That is 12 into 30. 12 into 30 minus 3 into 30. Okay. Now what is the case here? So 13 in stock and 13 he is selling. So what the situation? So 13 he can sell. You will get a profit of 30. Okay. Here also 13 he can sell. You will get a profit of 30. Here also 13 he can sell. He will get a profit of 30. So here what is the situation? Here 13 is the demand and 14 in stock. So 13 into 30 minus 1 into 30. So here also same way 14 into 30 he will get as a profit. Here also you can see 14 into 30. So he can get the maximum profit in these cases. So here what is the situation? 13 into 30 minus 2 into 30. Since 13 only he can sell at a rate of 30. For the two cases he is encountering a loss of 60. So that is taken into account. So here 14. So 14 into 30 minus 1 into 30. Here also the same way 15 into 30. So if I complete the matrix, so 13 into 30, so that is 390. So this is also 390. This is also 390. Okay, so this is 360. This is 420. And this is also 420. Here it is 270. Here it is 330. Here it is 390. And here it is also 450. Okay, so this is the way you will get the matrix. You will get the conditional profit matrix. Any doubt in the value that any doubt in any of the values regarding how I got the conditional profit table? Any doubt? We will discuss.
Sir, how are we getting that 13, 14, 15 in the under the state of nature demand?
It is given in the question. 1 minute. So 12, 13. So in the question, it is given as cases sold as 12, 13, 14, and 15. Okay. So
Okay,
the case, so from that data only I have taken the other data.
Okay, sir. I didn't actually see that case is sold. Okay, okay. So regarding the probability, sir, you are sorry, you are calculating 0.1, 0.2, 0.3, 0.4, right?
Yes.
Sir, that actually you put it as per that order, sir. Like, or is there any other way you used it?
No, this is 120 days. The data is for 120 days.
Okay, sir. Yes.
And the case 12 cases were sold on 12 days. Okay, the demand for 12 cases was on 12 days. Okay, so the fraction of 12 for 120 is 0.1.
Okay, sir. Now, okay, now I'm getting, sir.
Yeah, and
Okay.
the demand for 13 cases is 24 days.
So you're taking the ratios.
So the fraction of 24 and 120 is 0.2.
Okay.
With 14 and 15. That's how I'm getting the probability. If these values are going to change, definitely my probability value is also going to change. Only thing is that my summation should be equal to 1. That's all. Okay. Even if I interchange any of these to any of the cell values also, your total summation will be 120, but the probability value will correspondingly will change it. That's all.
Oh, so simply taking the ratio will do the purpose.
Simply taking the ratio will do it.
Okay, sir.
But what ratio has to be taken, that you have to be taken care. Sometimes it may be in proper units, sometimes it may not be in proper units, etc. So you have to take that into the that into your view, and you have to solve it.
Okay, sir.
Yeah. Okay. So any other
Sir?
doubts? Yeah, yes, please.
Sir, here one small doubt, sir. Here.
Yes, please.
And what is the meaning of this number of days here, sir? Like number of days required for selling 13 cases, 12 cases, or what, sir?
No, it is 12 cases. So 12 cases were sold on 12 days. That is, the demand for 12 cases is out of 120 days is only 12. Okay. So there is a demand of 13 cases. So the demand for 13 cases was 24 days. Okay. The demand for 14 cases was 36 days. And the demand for 15 cases was 48 days.
Okay, sir.
Clear? Got it?
Yes, sir.
Yeah. In any other clarifications, any other doubts or any other clarifications required? So now this is again demand per week. So same 12, 13, 14 and one minute. Okay. 14 and 15. Here you will have probability. This is expected profit. This is expected profit. Here there is no change. 12, 13, 14, 15. So this table, that is payoff table. This is called as expected payoff. Okay, expected payoff table. So probability same value 0 0.1, 0 0.2, 0 0.3 and 0 0.4. Okay. Now what is the now what will be the expected payoff? So you have to multiply each and every term with the corresponding probability. That is 36. Yeah. So 36. The 360 multiplied by 0.1. 360 multiplied by 0.2, 360 by 0.3, 360 by 0.4 in the first column. Second column 330 into 0.1 plus 330 into 0.1, 0.2 into 390, 0.3 into 390 and 0.4 into 490. Likewise, you have to multiply with the probability value and write the cost. That will be your expected payoff. So values will be 36, 72, 108 and 114. Second case it is 33, 78, 117 and 156. Here it is 30, 72, 126, 168. This is 27, 60, 117 and 180. And the EMV value will be the summation of these values. So I'll just add it to the so EMV will be just the summation of all this. So the value here will be 360. This is 384. This is 396 and this is 390. So the largest return is 396. Since we were talking about the profit table. Okay, we were talking about the profit table and the largest profit lies for largest profit is rupees 396 for 14 cases. So your decision. Okay, so the decision to purchase 14 cases daily. Okay, so since it is the profit we are calculating, largest profit is taken into account. Largest profit value is 396. So we are telling that the decision is to go for the largest profit, that is every day he has to stock 14 cases of strawberries. Okay, to get the maximum profit value of 396. So whatever the loss, if that is getting incurred for the lower part, that also will get stabilized if he stocks like this. So this is how an expected monetary value decision you have to make. Is the methodology, everything is clear? So the EMV is nothing but it is a summation of probability with expected payoff or expected profit or expected cost. Okay, and profit, the largest you have to select. Okay, cost, the lowest you have to select. That is the only difference. So this is demand. I'll quickly write the value. Demand is 0, 1, 2, 3, and 4. This is also 0, 1, 2, 3, and 4. This is probability. This is 0.93, 0.04, 0.01, 0.01, 0.01. So this is 0. This is 200. So I'm just reducing the 0 and writing. So 200, 400, 600, and this is 800. As you told, this is 10, this is 20, this is 30, and this is 40. So finally, this matrix is full of 40. This is the last alone is 230. This is 420, and this is 610. Okay, so you can fill off the matrix. Finally, you have to select the lowest cost. Okay, since the matrix is cost, okay, only you need to look only that. Rest procedure is same. Since matrix is cost, select lowest EMV. Okay, and once if you are solving, your decision will be 1. Okay, your decision will be once you solve, you can see your decision will be 1 gear train to stock. Okay, so that is the EMV method. So more details, more problems if you want to work out, please refer any books. Okay, plenty of problems will be available. Methodology remains the same. Cost, lowest EMI, profit, largest EMV. So that's the way you have to select. So quickly I'll go through the one more method, EOL, then I will stop today's class. So this is EMV we have calculated. Now there is a next term that is called expected opportunity loss. Okay, so that is basically the expected opportunity loss is the expected value of the regret for each decision. That is, if you have not chosen that opportunity, what will happen? Okay, that but it is not like the previous case that maximin or minimax or regret or Laplace or Hurwitz. Here whatever the decision is, decision will be same for EMV and EOL method. Okay, the only the idea or the working idea is only going to change, but results are not going to vary. Results will remain same in the case of EMV and EOL condition. So the same probability is taken into account. So you can see what the same way the regret table we are making, expected opportunity table we have to prepare, and expected opportunity from the expected opportunity table you have to multiply with the probability. So how are we converting into the opportunity, that expected opportunity table? How are we converting it? The same way you have to find. Okay, so you have to find what, how are we doing it? So what are our previous value? So it is 50,000, 1 lakh and 30,000. So find the largest. Okay, find the largest value in the column wise. Okay, find the largest value in the column wise and you are subtracting it. Okay, you are subtracting it from all other elements of that particular column. So here 1 lakh is the largest. So 1 lakh you are subtracting. So this will be 50,000. This will be 0 and this will be 70,000. You got it over here as the first column of the regret table. Second column, 30,000 is the largest. So 30,000. So this becomes 0. Okay. So 30,000 minus 40,000. So you will get as 70,000, and 30,000 minus 10,000 you will get as 20,000. Then multiply with the probability. You sum it up, you will get the expected opportunity loss value. Same way of that of EMV. Only thing is that instead of getting a conditional profit table, you have to find an expected opportunity loss table. Okay, by multiplying with the probability value and summing up. So for getting that information for the conditional table, you have to prepare a regret table. For getting the regret table, take the largest value in the column wise. Okay, in the column wise. Okay, and subtract it, the other elements from it. Prepare a regret table. From the regret table, multiply with the probability. Okay, and sum it up. You will get the EOL value, expected opportunity loss value. Okay, and EOL and EMV, the value remains the same. Is that clear? I'll straight away I'll give you a problem for you to work out. Action and event. This is E1, E2, E3 and E4. This is A1, A2, A3 and A4. Values will be 40, 200, 0 and minus 50. So this is 200, 0, 100, 400, minus 200, 200, 0 and 100, 100, 0, 150 and 0. And the data given as P of E1. P of E1 is 0.20. P of E2 is 0.15. P of E3 is 0.4 and P of E4 is 0.25. Okay. So question is prepare EOL and EMV table. Okay. What will be the decision? What will be the decision if the matrix is cost? Same way, what will be the decision if the matrix is profit? Yeah. So that's a question. So how to proceed? So good evening all. So last class I think I given you a problem for you to solve. I hope you have worked out. So prepare an EOL and EMV table. What will be the decision if the matrix is cost, and what will be the decision if the matrix is profit? So have you solved this? So here one more thing you have to take into account, that P of E1, E2, E3, etc. is given. So the matrix you need to reverse. Okay, you need to reverse the matrix. Then only you are supposed to solve it. Okay, so once you solve it completely, so you will get the values as something like this. So for whoever solved can verify your result. So I had action A1, A2, A3 and A4. And expected payoff, that is EMV, will be minus 17, 120, 52.5 and 90. Here it is 234.5, 92.5 and 165.0, and it is 127.5. So you can see in the case of a profit, we will normally go for maximum EMV. So maximum EMV here is 120. Okay, so maximum EMV is 120, and you can see the corresponding EOL will be the minimum. Okay, the corresponding EOL will be the minimum. Okay, and minimum EMV you can see over here, that is minus 17. Okay, corresponding EOL will be the largest one. So this is what we have told. What this is what I had told you earlier, that if the EMV is max, EOL will be minimum. If EMV is smaller, EOL will be larger. So the decision indicating by EMV and EOL will be the same. Okay, the decision indicating by EMV and EOL will be same. So 120 will be in the case of profit, minus 17 that will be in the case of cost. So this is how you have to make the decision by using EMV or EOL table. Okay. So we'll go back to our slide itself. So there is a third model is available. So this is already we have discussed. I'll move to the third one. So decision making with probabilities, expected value of perfect information. So expected value of perfect information is the maximum amount a decision maker would pay for additional information. EVPI equals the expected value given perfect information minus the expected value without perfect information. So EVPI equals the expected opportunity loss for the best decision. Okay. So EVPI, if I want to calculate, you have to first calculate EPPI. So EPPI minus maximum EMV, that you will get EVPI value. Okay, we will see. We'll see a problem. So decision with perfect information. Okay, so you can see you have already. So this is taken in terms of EOL. So I can take this in terms of EMV also. Okay, so decision with perfect information. So this is if here you can see. Here they have given the condition is given 0.6 and zero point 0.4. So 0.6, you can see the maximum return here in the first case is 1 lakh and the second case it is 30,000. So 1 lakh into 0.6 plus 30,000 into 0.4. So I got the value as 72,000. So decision with perfect information. Okay, so I am calculating. So 1 lakh into 0.6 minus 40 lakhs into 0.4. So 44,000 I am getting and I am taking the result. Okay. So this is a third method. So I'll solve with a different problem for a better understanding and for a better clarity. So you can see there is a problem is here. So you can just read the problem. So it is regarding a milk producing cooperative union desires how many kgs of butter it should produce on a daily basis to meet the demand. Past records have following pattern of demand. So quantity is varying from 15 kg to 45 kg over a days of 4 to 10. Okay. Assume that the stock levels are restricted to the range of 15 to 45 kg, a multiple of 5 kg, and that the butter unsold at the end of the day must be disposed of due to inadequate storage facilities. Butter costs rupees 40 per kg and is sold at rupees 60 per kg. Okay, construct a conditional profit table. Determine action alternative associated with maximization of expected profit. Determine EVPI. So here it is maximization of expected profit. It has been asked. And determine EVPI. So that is the question. Okay. So now how to proceed? So first you have to construct a profit table for the given condition. So it is 15, 20, 25, 30, 35, 40 and 45. Okay. I think I can copy this table one more. Okay, so the first column it is possible demand. Second column is probability. Third column onwards possible stock of action. It is possible stock of action. So the I'll write here, that will be better. So there is possible demand. This is probability. This is possible stock of action. this is 15, 20, 25, 30, 35, 40 and 45. Yeah. So this is again 15, 20, 25, 30, 35, 40, and you have 45. Yeah, okay. Now tell me what is the what is the profit? What is the profit and what is the loss? What is the profit and what is the loss? So profit has 60 for 60 minus 40, that is 20 rupees 20 per kg. Okay, rupees 20 per kg. And losses, if it is not sold, the next day it is minus 60 is loss per kg, 60 rupees loss per kg. Okay, and probability you can total it up. So when you total it, what's the value you will get? I think you will get it as 200. So you will get it as 200. So the fraction of 4 out of 200, that will be 0.02, 0.02, 0.08, 0.10, 0.40, 0.20, 0.15 and 0.05. I hope that part is clear. You don't have no issue. You have no issues in that part. That that idea is very much clear to you. Am I right? Am I right? Okay. So now if 15 kg is in your stock and and 15 if you are selling, okay. So 15 into 20, you will get a profit of 300 here. Next column will be 20. So the 20 means 15 kg you can sell and 5 kg is loss. So 60 per kg you have to incur as loss. So that value will be 100. So that will be something like 15 into 20. Okay, 15 into 20 minus 5 into 6. Okay, minus 5 into 6. Yeah, so 100. So this will be minus 100. This will be minus 300, minus 500, minus 700, minus 900. Okay, so entire this column it will be 300. Okay, that remains as it is 300. Thus 100, the next column here it is 40, sorry 400. Rest all this remains the same value as 400. So this here is 200, this here is 500. So rest it is 500. So 300 you will have 0. Then you will have another 300 here as plus. Then you will have 600. So rest it remains the same. Minus 500, minus 200, 100, 400, 700. Rest values are 700. This is minus 700. This is minus 400, minus 100, 200, 500, 800, last value is also 800. So minus 900, minus 600, minus 300, 0, 300, 600, 900. So that is a conditional profit table we have made. Okay, so you know the name of the table, so that is called as the conditional profit table. Conditional profit table you have made. So once you made the conditional profit table, you know what to be done next. What to be done next? You can calculate the expected profit table. Okay, so how to calculate the expected profit table? You have to multiply the probability, the corresponding probability. Yeah, so the corresponding probability you have to multiply. Okay, and when you multiply and when you sum it up, you can get the value of EMV. The expected monetary value you can get. You can even calculate EOL also. You have to prepare a regret table from the given table and you can perform the EOL value also. Okay, so that is up to you. So I'm just I'm not substituting any of the values here. You can multiply directly with the probability for checking. So this is 6, this is 24, this is 30, this is 120, this is 60, this is 45, and this is 15. And if we see the EMV values, it is 300, 300, I had 394, I had 464, I had 504, then 424, then 284, and then this is 99. You can substitute and you can solve. So the maximum EMV lies at 504. Okay, I just highlighted it over there. Now we will see how to calculate. Yeah. So how to calculate for the so this is the expected profit table. Expected profit table. So the next one you have to see how to get the information for the perfect information. So perfect information, it is simple. So possible demand is 15. Okay, and the conditional profit under certainty. So I'll just modify this table. Then I had the data for 15, 20, 25, 30, 35, 40 and 45. So this is possible demand, the first column itself. Second is probability. Third is conditional profit under certainty. Conditional profit under certainty. And next is expected profit. Expected profit with perfect information. Okay, so I had demands for 15, 20, 25, 30, 35, 40, and 45. Probability will be 0.02, 0.08, 0.10, 0.40, 0.20, 0.15, 0.05. So if 15 kg is in my stock and if I sold the 15 kg itself, I will get a maximum profit of rupees 300 that I can get it from the first table here. So 15 is in stock and 15 if I'm selling, I'll get a profit of 300. And 20 in stock and 20 if I sold, I'll get 400. Then it is 500, 600, 700, 800 and 900. 4 corresponding stocks of 25, 30, 35, 40 and 45. So that is the value I am entering here in the column. So 300, this is 400, this is 500. So that is the conditional profit with certainty. That is, if 100% sure that I sold that product, this is the profit with this is a conditional profit which I am getting. So 500, 600, 700, 800 and 900. But the chance of getting 300 is only 0.02. So multiplying that 300 with that 0.02 and writing here. So that is my expected profit with perfect information. If I sum it up. So 6, 32, this is 50, this is 240, this is 140, this is 120, and this is 45. So here the EPPI, this is the expected profit with perfect information. EPPI equals 6 plus 32 plus 50 plus 240 plus 140 plus 120 plus 45. So you'll get the value as 633.00. That is only expected profit for information. You have to calculate EVPI. Okay, so you have to calculate EVPI. So EVPI equals, okay, EPPI minus maximum EMV. Since it is a profit, it is maximum EMV. If it is a cost, it will be minimum EMV. So 633 minus 504. 504. So that is rupees 129. So this is the additional cost which is incurring. This is the additional cost which you are incurring or which is required for getting the expected value for perfect information. So these are the methods in which you can solve the problem. Okay, you can solve the problem when conditions are given to you. Okay, so here the probabilities are known. Using the probabilities, you are finding the decision by using EMV method, by using EOL method, or by using EVPI method. So any method, the decision is going to be the same. Okay. So any doubt so far in any of the calculations? Any doubts in any of the calculations? Yeah, okay. So if no doubts, I'll move to the next part in this. Okay. So that is called decision tree. Okay. So under risk criterion. So if you want to calculate or if you want to make the decision easily by plotting for the by plotting it for the various uh, by plotting it for the various alternatives by using a tree approach. So that is called the decision tree. So a decision tree is a chronological representation of the decision problem. Okay, so normally EMV methods are used to make the decision by using decision tree. So probabilities are known. Using the probability, you can split the nodes or you can branch the tree. Okay, each decision tree has two types of nodes. Round nodes corresponds to the state of nature, while square nodes corresponds to decision alternatives. Okay, the branches leaving each round node represent the different states of nature, while the branches leaving each square node represent the different decision alternatives. At the end of each limb of a tree are the payoffs attained from the series of branches making up that limb. Okay, so this is what is basically the tree is. So let us take a problem and let us see how to construct a tree. Okay, so you can just read the problem for a minute. What is it? So a contractor has a choice between two courses of action. So one is a risky contract promising rupees 10 lakhs with a probability of 0.6 and 6 lakhs with a probability of 0.4. And B is a diversified portfolio consisting of two contracts with independent outcomes, each paying 5 lakhs with a probability consisting of 0.6 and rupees 3 lakhs with a probability of 0.4. Okay, so I'm just plotting the tree. So initially, as I told earlier, so there is a square node. So I had a square node initially. So node number is given as 1. So 1 is my final decision. Okay, so I had two options. One is to go for A, or next is to go for B. Okay, so it is a round node. Okay, so node number 2 and node number 3. So node number 2 is choose risky. Is to choose risky, and here it is diversified portfolio. Diversified portfolio. Okay, now if we choose a risky project, what will happen? There are again two options are there. Risky contract promising rupees 10 lakhs with a probability of 0.6. Okay, risky contract will again, he will get a profit of rupees 10 lakhs and the probability is 10 lakhs and the probability is 0.6. What is the next option? 6 lakhs, and there is a 6 lakhs with a probability of 0.4 lakhs. Okay, so if it is failure, the probability, the chance of failure is 40%. If it is 40%, he will get only 6 lakhs. Okay. Now, what is the bottom criteria saying? A diversified portfolio, again consisting of 2 contracts with independent outcomes, each paying 5 lakhs. Okay, each paying 5 lakhs with a probability of consisting of 0.6. Yeah. So first I have drawn. So that is of 5 lakhs. And the chance is 0.6, and here it is and with a probability, and 3 lakhs with a probability of 0.4. Okay, so these are the so this is how you are plotting the decision tree. So all the condition given in the problem, you have entered it. Okay, all the conditions in the problem, you have entered it. Okay, is the construction part clear? Now let us see how to compute back. So first you have to calculate at the node number. So we are again calculating EMV. Okay, EMV at node 2. So node 2, my total returns will be 10 into 0.6 plus 6 into 0.4. The output will be rupees 8.4 lakhs. Okay, so here I can write the value as 8.4. Okay, now same way down. So EMV at node 3. So that is 5 into 0.6 plus 3 into 0.4. So you will get a value of rupees 4.2 lakhs. So I can write here 4.2. So now there is no probabilities given over here. So straight away I can say that which is the best, which EMV is giving me the best result. So the best result is still 8.4. So which path I can choose? I can choose risky project. So the result is choose risky project. So by this way, if you are plotting and getting the values and finding solutions for a problem, okay, that is called the decision tree approach. Okay, so that methodology is called as the decision tree approach. Okay, so the same is shown over here. The same is constructed over here. The same is constructed over here. Nodes are calculated and the final solution to choose the risky project is shown over here. So this is how you are calculating the decision tree. Okay, we'll try another problem. Yeah. Just try to plot it. So initial node, from the initial node, 3 options are there. to go ahead and launch, to run a test market, and to abandon the model. Okay, so if I launch the product, what will happen? Again, three options may happen. One, it can end up with an excellent demand, or it can end up with a good demand, or it can end up with a poor demand. So the excellent demand, the probability is 0.4, good demand, the probability is 0.4, and for poor demand, the probability is 0.2. Okay. Now I run a test product in a test market. So if I want to run a product in a test market, I need to spend an investment of rupees 2 lakhs in addition. Okay. And the test market results may be favorable or it may be unfavorable. The chances are 50:50. That is, probability is 0.5 for a favorable condition, and for an unfavorable condition also the probability is 0.5. If it is a favorable market and you are launching the product, again it can be of three outcomes. Either it can be of poor demand, or it can be of good demand, or it can be having excellent demand. Similarly, in the case of unfavorable market also, it is again going to change in such a way that it can be poor, good, or excellent demand. So that is how the tree has to be plotted. So my first node I am plotting. That's a square node. That is a final decision. So node is 1. From the node 1, there are three options are available. One is to launch the product, run the product to a test market, and third is to abandon the model.
Sir,
Yes, please.
sir, is the favorable costing 11.8 lakhs, sir?
1 minute. Favorable?
Is it costing 11.8 lakhs, sir?
Which favorable? Run the test market?
Yes, sir. I don't know it's correct or wrong, sir. I just know trade.
No. What did the launch of the product got the value?
Oh, sorry, sir. I made a small mistake. Okay, sir.
Yeah,
Sorry.
that 2 lakhs has to be deducted.
Yes, sir.
Okay, so this is to launch. This is to run a test. And this is to abandon. To abandon the model. So run a test market, it will cost me 2 lakhs. So that 2 lakh has to be subtracted everywhere. Yeah. So if I launch the product, again, three conditions may happen. One is it can be favorable. Sorry, it can be poor, it can be good, or it can be excellent. Okay, so this can be poor demand, this can be good demand, and this can be excellent demand. So poor demand, it will end up in 4 lakhs. Good, it is 8 lakh. And excellent, it is 14 lakh. So the probability will be 0.2. This is 0.4. And this is also 0.4. So you can calculate the nodal value at node number 2. You can calculate the nodal value at node number 2. Okay. Now what next? So if I run a test product, again there are two outcomes are there. One, it can be a favorable market or it can be an unfavorable market. So that is my node number 4 and this is my node number 5. So this is favorable and this is unfavorable. So the chances of favorable and unfavorable is 50-50. So 0.5 and 0.5 here. Now, even if it is a favorable market, again, there are three chances are there. It can have a poor demand. It can have a poor demand. It can be a good demand or it can have an excellent demand. The same is that here also the same is the case. So it can be poor, it can be good, or it can be excellent. So poor, good, or excellent. So if it is a good, okay. So favorable market of poor, you will have the probability is 0.1. The return is 4. But you have to spend a 2 lakhs for running it into a test market. So that amount you have to subtract. Good one, the probability is 0.2. You will get a return of 8 lakhs minus 2 lakhs. So that will be only your output. And excellent demand, the probability is 0.1. Sorry. Yeah. Okay, so it is 0.7. So that is 0.7. So excellent, it is 0.7. So return as 14, 14 minus 2. Okay, same way in the down, it is again 4 minus 2. Your probability is 0.2. For a good, your probability is 0.8. Good is 0.1. Excellent is also 0.1. So 4 minus 2, 8 minus 2, and 14 minus 2. So here also the same way like our previous case. You can calculate from the back. So first is EMV at node 4. Okay. So EMV at node 4, what is the situation? So 2 into 0.1 plus 6 into 0.2 plus 12 into 0.7. How much? So that is 9.8. So 9.8 lakhs. So I'll write here 9.8. Similarly at node 5, so this is 2 into 0.8 plus 6 into 0.1 plus 12 into 0.1. You will get the value as 3.4. Okay. So now node number, so EMV at node 4 first, node 5 next, then you can go for node 3, then you can go for node 2. So this is the order which you have to calculate it. So this is 3.4. So node at 3. So what is the value at node 3? So that is 3.4 into 0.5 plus 9.8 into 0.5. Okay, so that is 9.8 into 0.5 plus 3.4 into 0.5. So the value is 6.6. So here it is 6.6. So at node 2, the value will be 9.6. And at node 4, the value will be, what will be the value at node 4? That will be 0. Okay, so since we are talking about the profit, okay, since we are talking about the profit, so largest EMV we need to select. Okay, so largest EMV we need to select. So largest EMV is 9.6. So decision is launch the product directly. Launch the product directly. Okay. So using the nodal informations, you are calculating and you are solving the problem in the okay, from the reverse to the final decision you are making. So the square node is your final decision. All the round nodes needs to be solved, and then you can get the information about the square node, and final square node is your decision. Is the methodology is clear? Now a problem is that you can take a screenshot. You can try to solve. Some examples are given here. Okay, so these are things you can work out. And if you have any doubt, we will discuss on tomorrow.